So we took that data, we graphed the points, we made a best fit line, which is just an estimate of that line. We found 2 points on the line, and then here's how it would look after you put it into the equation and finding an equation in y equals mx plus b form. Now this is just an approximation, but it can be used to predict different years off in the future. But again, it's only an approximation, and if you want a more precise approximation, what you can get is a regression line. Now, there's a number of websites, calculators, apps, software, also maybe a spreadsheet, where it will calculate a regression line and a regression equation for you. First, you need to put your x's and y's that you have into the format somehow. Then what you do is you tell it that you want a y equals mx plus b, or a linear regression equation. There are other types of regression equations. And then it will give you a calculation. In this case, it gives this equation. Now that equation is different than the one that we got by making a best fit line. The values are similar, but it's not the same. But it's calculated based on these values, and its processes get a better estimate than we can just by fitting a line like we did. Now, what's the point of this regression equation? Well, you can use it in a couple of different ways. You can put a different year in, like maybe 2016, since we don't have data for that. And you can get an estimate of what kind of sales you're going to have in the future. Or you can do something like this. You can put in 2015, get that predicted value, and you can compare it to the actual value. And if you subtract those two amounts, that's called a deviation. And a deviation is just a measurement of how far off your actual and your predicted value are. This is a regression equation. It's useful because it's a lot more precise than just a best fit line.